Okay, we're going to begin lesson 10.1. We're in module number 10 now, which is on polynomials. We're going to begin by looking at how to add and subtract these different polynomials together. We're going to look at identifying polynomials given special names, also being able to write them in standard form, and be able to determine the degrees of the terms of a polynomial. Okay, so the first thing is we look at the types of polynomials. What is, number one, what is a polynomial? Well, a polynomial is either a monomial or a sum of two or more monomials. To be more clear, a monomial itself um, is a number, a variable, or a product of a number and one or more variables. So a monomial is when we're multiplying numbers and variables together. So what you see is there's no addition or subtraction sign. It's just a product, a mass of numbers and variables put together. Okay. And then these monomials, when they're joined together with addition signs or subtraction signs, then they become polynomials. So really, we need to start with a monomial concept first, and we'll look at some examples of these here in a minute. I also will call monomials, as well as anyone else in math, a term. So these monomials are the parts of a polynomial, and they'll be referred to as terms of this polynomial. Okay, a binomial is simply specifically having just two monomials added together. And a trinomial is when we have three of these monomials added together. Okay, so obviously bi is 2, tri is 3, so mono is 1. So these are all considered polynomials, but we have specific names for these three. Now, if we have 4 terms, 5 terms, 6 terms, we don't have anything special names for those. We just call all of those polynomials. So these are all under the polynomial family. These three just have more specific names. All right, tonight you're going to be asked a question of whether or not something is a polynomial. And the easier way to do this is to look at what isn't a polynomial. Now, when we talk about polynomials, we are talking about expressions. So there's no equal signs in these. These are just statements. Okay, so here are things that eliminate an expression from being a polynomial. First thing you have to do, though, before we determine that is we have to make sure it's simplified. So if there are like terms in our expression, we want to combine those first before we make a determination, because by combining them, it may bring it to a polynomial or it may make it not a polynomial. So we have to simplify things first. But here are two things you're looking for. Number one, no negative exponents. If we have a negative exponent in our expression that's given to us, it's not a polynomial. The second one there are no rational exponents. So rational means fractions. So, just a couple of examples here. If one of your terms in your polynomial was, let's say, x to the negative second, it would not be considered a polynomial. If one of your terms contained a variable like x to the 2/3 power, because that's a rational exponent, that one would not be considered polynomial. So we really look for those two things primarily when we're eliminating possible polynomial expressions. And it'd be easiest when we look at some examples. The other thing we'll look at are degrees of polynomials. So a degree of a polynomial, or even of a monomial, let's start with one term, a monomial, is we will take the sum of the exponents of all of its variables. So a monomial can have multiple variables in it. We won't get to this until tomorrow, but it could. And what we'll do is, if there are multiple variables in the monomial, we'll take each of their exponents and add them together, and that will be the degree for that term. Okay. When you're looking at a polynomial now, a polynomial is when we have more than one monomial added together. So a polynomial begins at a binomial and then a trinomial, and then you could have 4 terms and 5 terms. There's no limit to how many you can be adding together. But when you have a polynomial, what you'll do is you'll find the degree of each term separately. And then the biggest of those is what we name that polynomial to have a degree of. Okay. So, and again, you'll see these in examples, and I'll try to refer to these as we're going through things. But we also have names for the different degrees of polynomials. Okay, so if you have a degree of 0, that's considered a constant polynomial. And what that means is there's no variables in it. So there's no variables to add up exponents for. So it's just a constant, which means it's just a number. Okay, you can have a linear polynomial. Linear polynomial is when the degree is 1. So that means you have just like an x, which is x to the first power, which is a degree of 1, and that's all you have. So linear is when you just have a single variable itself. Okay, quadratic is when you have a degree of 2. So you have a variable raised to the second power. That would give you a degree of 2. That'd be called a quadratic. A cubic polynomial is when the highest degree is 3. A quartic is when the highest degree is 4. Quintic is when the highest degree is 5. And then when we get bigger than that, we just say it's a 6th degree, 7th degree, 8th degree. We don't really talk about these much. The last couple, the first, second, third, we'll deal with those. You know, the linear, quadratic, cubic, we'll deal with those. Not so much cubic, but definitely quadratic. And you've already dealt with these, but just we haven't talked about it in this way. Okay, next idea is standard form of a polynomial. All right, so we all want to be able to write our answers the exact same way. And to write them the same way, we have what we call a standard form. So when everybody is writing their answers, they'll all look exactly the same. There'll be no variation to it. And here's how we do standard form. All right, in standard form, what we're going to do is take the terms of the polynomial. So we have, however many terms there may be, and we're going to put them in order from the greatest degree to the least degree. So we're going to go biggest degree down to the smallest degree. All right. And then because addition is commutative and in a polynomial, we are adding the terms together, we can easily rearrange them to do this, to put them in order from greatest to least. So that makes it nice. Make sure we understand subtraction signs. Now polynomials can be added or subtracted. It's one and the same for us. All right. And we got to understand that subtraction signs are attached to the term that follows. And what that means is it almost makes the term that follows a negative, and we will look at those here in a second as well. And then the last thing we'll do when we put things in standard form is we'll identify the lead coefficient, and that is simply the number that's attached to the first term. All right, so when I get them put in order, so when I get these polynomials put in order with the biggest degree first, whatever the number part attached to that biggest degree is, that's our lead coefficient. All right, I know this seems very abstract right now, but when we look at an example, I think you'll understand what we're talking about. So let's start by looking at some examples of polynomials and talk about the degree and classification, or even if it is a polynomial. All right, so our first example here is 3z to the negative second. Okay, it looks like it's a monomial. It's one term because you have a number times a variable to a power. So that would be a monomial typically. However, what I said was one of the things that will eliminate an expression from becoming a polynomial is a negative exponent. So because of that z to the negative second right there, this is not a polynomial. And if it's not a polynomial, according to this standard, if it's not a polynomial, then we don't worry about degree and we don't worry about classification. It's got to be a polynomial for us to talk about degree and classification. Okay, let's look at our second example, B here. 2x cubed plus x minus 12. Okay, so when you look at this, what I want you to see is this addition and subtraction. What those two are doing is separating terms. So the first term is 2x cubed. That's a product of a number and variables. X cubed is x times x times x. So that's all multiplied together right there. So that's our first term. Our second term is the x. And our third term is this negative 12, or minus 12 becomes a negative 12. So there are three terms here. Okay, first question, is it a polynomial? Well, look at your variables. Are all my variables to a positive exponent? This is to the third power. This is to the first power. That's positive. So yes, this is a polynomial. What would its degree be? Well, okay, let's look at our first term. The exponent in the variable is 3, and it's the only variable we have. So the first term has a degree of 3. The second term, which is this x, is to the first power, so it has a degree of 1. And the last term is a 12. It doesn't have a variable, so we would say this has a degree of 0. So I got a degree of 3, degree of 1, degree of 0. So of those, the 3 is the biggest. So the degree of the polynomial is 3. Okay, classification, if it's a degree of 3, it is a trinomial. Okay, it is a trinomial. There are 3 terms. They asked us to classify it here. If I had to classify it by its degree now, I would say it is cubic, right? We said anything to the 3rd degree is cubic, but this classification meant what of these binomial, trinomial was it? Okay, C. C is a product of a number and a variable. That's all you got is a product right there. There's nothing added to it, subtracted to it. It's one term, I would say. It's a monomial term. So there's just one term here. Now it's raised to the b. If I had to put an exponent, it would be to the first power. Okay, that's positive. So is this a polynomial? Yes. What's the degree? Well, the the exponent on b is a 1, so that's to the first degree. And then classify it by its number of terms. There's one term, so it's a monomial. Okay, D. Okay, it's 9x minus 2. So 9x is the first term. Remember that minus and addition and subtraction signs separate our terms. So there's 9x is a term, the 2 is a term. Okay, so I got 2 terms. Look at the exponents. This is to the first power. This has no exponents to us as a 0 power. So number 1, I guess, is it a polynomial? Well, the exponents are positive. Everything looks good, so yes. What's the degree? Well, this is to the first power. This is to the 0 power. Out of those two, which one's bigger? First power. So it's got a degree of 1. And then how many terms is there? Well, there's the first term and a second term. So there's 2 terms, so it's a binomial. Okay. Now, I'll constantly try to talk about these concepts as we go through questions that won't be specifically geared to, naming these concepts, but we'll just try to keep familiarizing ourselves with those ideas. Okay. Now, this question is asking us to take this polynomial and write it in standard form and then identify the lead coefficient. Well, let's talk about this first. How many terms are in this polynomial? Whether it's 1, 2, 3, 4 terms. There's 4 terms. So monomial, binomial, trinomial are 1, 2, and 3. If we have 4 terms, we don't have a special name for it. We just call this thing a polynomial. Okay. Now we're supposed to write this in standard form. So the first thing I'll always do is say, is this simplified? Which means, are there any like terms I can combine? Well, this is just an x to the first term. This has no variable. This is x to the third. This is x squared. So since none of my exponents on my variable are the same, none of them are the same type of term. So I can't combine any of this. Okay. So the second step is, since we're only asked to be writing this in standard form, I write it in standard form based on the degree of each term. So let's identify them. The first term, 4x, has a degree of 1. The exponent on the variable x is 1. Okay, the 12 is a constant term. The constant has a degree of 0. 2x cubed, the exponent's 3, so this has the degree of 3. Minus 3x squared, the exponent is 2, so this degree is 2. So there are the degrees of each of my terms. To put it in standard form, we rewrite it in order from the biggest to the smallest degree. So that my largest degree is the 3, which is this term. So that comes first, 2x cubed. Then go to 2. Well, remember now, a minus sign means this has got to travel with this term. So minus 3x squared has to be my next term, minus 3x squared. And then 1 would be plus 4x. And then my last one is always the constant, because a constant always has a 0 degree, so plus 12. So it's the same 4 terms. I just rearranged them to put them in order from greatest term to least term, greatest degree, to least degree. Last question was identify the leading coefficient. So we don't know what the lead coefficient is until we put it in standard form. So the lead coefficient is the number attached to the first term, which is 2. Okay, so that's writing this in standard form. Let's look at our second one here. Okay, again, I have 4 terms. The 5b is a term, the negative 10b squared is a term, the 35 is a term, the negative b cubed is a term. So there's 4 terms. All right. Is it simplified? Well, b to the first, b to the second, no b at all, b to the third. None of these are b to the same power, so I can't combine any of this. So it's going to be stuck at 4 terms. Let's look at the degree of each term. All right, the degree of 5b, well, it's b to the first, so that degree is 1. 10b squared, degree of 2. 35 is a constant, that's a degree of 0. B cubed is a degree of 3. Okay, now rewrite it from greatest degree to the least degree. So this one's going to come first. Remember, these minus signs in front got to travel with that term. So this is going to be a negative b cubed first. Okay, then the degree of 2 is minus 10b squared. And then my degree of 1 is 5b. And then my constant's last, which is 35. Okay, so that's now in standard form. Same 4 terms, just rearrange so that it goes biggest degree to smallest degree. Lead coefficient is the number attached to the first term. Well, it's minus b cubed, but we can always understand that there'd be a 1 there. So my leading coefficient is really negative 1. Okay, so that's a little exercise in writing these in standard form, these polynomials. Okay, now get to the kind of the main stuff here. Adding and subtracting polynomials. It's pretty simple to add and subtract polynomials. Okay, got a couple of steps here. To add polynomials, when it's addition between my polynomials, I can drop the parentheses. After I drop the parentheses, I want to combine any like terms. That means I'm looking for base numbers to the same power, same base to the same power. We'll talk about this in a second. And then the last thing, as I'm combining like terms, I'm going to put it in standard form. I'm going to take the highest degree, simplify that first, then the next degree, and then the next degree, and I'm going to work my way down. Okay. When we subtract polynomials, it's really the same process, but there's one key part to it to start with. That subtraction sign in front of that grouping symbol, when it's minus a grouping symbol, means we have to subtract each term in that parentheses that follows that subtraction sign. Okay, so that's huge. We'll work on that here in a second. Okay, but after I've done that, then it's combined like terms. And as I'm doing it with the idea in mind that I'm going to write it in standard form. Okay, so it's kind of an asterisk right here. This is a key part of subtracting polynomials, is that minus sign in front of a grouping symbol means everything in that grouping symbol has to get subtracted. And I'll show you how to do that. So let's start with some addition first. So it says find the sum. Okay, so I got a trinomial here and a trinomial in this parentheses. Okay, now the parentheses are there usually to help us determine that maybe this was some kind of a given problem, and this was one of the numbers and this is the other number, something along that lines. Once we get this given to us, though, you got to ask yourself, is the parentheses, this first set of parentheses, is this needed? Is it indicating that we're going to distribute, like we got a number out in front, we're going to multiply and distribute through? No, there's nothing there. Is it raised to a power? Is this trinomial raised to a power? No, that's not there. If none of that occurs, then I don't need those parentheses and I can drop them. Same thing for the second set, but more importantly for the second set is what's the sign prior to it? If it's addition, then I don't need the parentheses. If there's a number being distributed through, I got to do that, but there's nothing like that here. If there's a power out on my parentheses here, I got to deal with that, but there's nothing there. So both sets of parentheses here aren't needed, so I can drop them. So now what that shows me is these 3 terms added to these 3 terms. More importantly, it's just 6 different terms put together. Okay, now that I've kind of broken it out of the parentheses, now I'm free to pair them up as I need to. So here we go. My highest degree is the 2, x squared. So I'm going to take those x squared terms and I'm going to put those 2 together because they're the highest degree. So they're going to come first when I put it in standard form. That gives me 5x squared, 3x squared, 2x squared, 5x squared. So now I'm done with my x squared terms. Move to the next one. That would be my x terms. I got 9x, 4x. Okay, 9x and 4x is 13x. So now I've handled those terms. Last of all, I got 27 and negative 12. 27 and negative 12 would give me 15. And now I've completed those two. So now when I look up here, I've taken all 6 terms, I've combined any like terms together, and I've written this answer in standard form. That's what it should look like. Okay, go to my second one. Ask the same questions. Is this first parentheses necessary? Are we distributing a number through? Do I have it raised to a power? Is there a minus sign in front? No, none of that. So I can drop that one. Second parentheses. Is there a minus sign in front? No. A number to distribute through? No. A power out here? No. So I can drop that one. And now I just have these all listed together. And now this allows me just to pair them up and simplify them. So what's the highest degree? X squareds. This is a negative 1. Remember, that sign in front's important. That's a negative 1, a positive 2. Negative 1, positive 2 is just x squared. So I've handled my x squared terms. Now there's 3 terms left, and of the 3 terms, the 4x is the only x term up there. There's no other x term to match with it, so that comes down, and I'm done with that one. And then finally, the constants are always done last, which are the numbers. 8 and negative 9, that's negative 1. I've completed those, so I've taken these two and added them together. Okay, and that's my final answer here. All right, let's look at subtraction. Now this changes things a bit, okay? So, as we give in this problem, we start out with the same concept. Do I need the parentheses? So this first set of parentheses here, is there a minus sign in front of this parentheses? No. A number to distribute through? No. A power that I have to deal with out here? No. So I can drop that first parentheses. The second parentheses, though, I don't have a number to distribute through. I don't have a power out here, but I got this minus sign in front. So I cannot just drop this parentheses. This minus sign in front means I got to subtract each one of these individually. Okay, so I'm going to do that in this step. So I got to go minus 5h squared, minus 5h squared, minus negative 2. Now, minus a negative 2 is really plus 2. And then minus 8h, which is going to be minus 8h. So I've now taken that minus sign and I subtracted each of those. And now I've got my statement how I like it. Okay. Very important you take the time to do this step so that you're getting these signs correct. Now at this point, it's just like the last question we did. Let's start pairing up, if we can, any like terms. So I start with the highest degree. This is negative 1h and a negative 5h, negative 1h squared and negative 5h squared. So when I put those together, I get negative 6h squared. And now I'm done with my h squared term. Next are h to the first, which are h terms. And if you look, there's 3 of them. I got h, minus 2h, minus 8h. It's okay. We can have it. They can put together as many terms as they want us to. These are all like terms because they're all h to the first power. Okay, so I kind of think of it this way. Negative 2h and negative 8h is negative 10h. Negative 10h plus 1h is going to be negative 9h. And now I've taken all 3 h terms and put them together. That leaves me with just the constant, and there's only one of them up here, which is 2, so bring that down. And now I've combined all my terms, I've simplified it, and I've written it in standard form. Okay, let's do another one. So this, I have a trinomial minus a trinomial. That really doesn't matter that it's a trinomial minus a trinomial. This is a polynomial minus a polynomial. That's all really that matters. Okay, so look at each parenthesis. So the first parenthesis, do we need to have it in? Do we need to keep it? Is there a minus sign in front of it? No. A number to distribute? No. Is there a power out here? No. So we can drop it. Second parenthesis, do we need that one? Well, yeah, because there's a minus sign in front. So I got to keep that one as is. Now, I want to eliminate the parentheses, and to do that, I got to subtract each of these terms, and then I can drop the parentheses. So the first one's already dropped. I'm going to leave it as is. Now here, I'm going to go minus negative 16r squared, which becomes plus 16r squared, minus negative 7r plus 7r, minus negative 3 plus 3. So now I've gotten rid of the second parentheses by doing the subtraction process it asks us to. Now I have just a list of terms here. I have six different terms. 8r, negative 14, 7r squared, 16r squared, 7r, and 3. And now we're going to combine like terms. So what do we get first? We always start with our highest degree because that's going to come first in our answer. 7r squared plus 16r squared, 23r squared. Okay, go to your r terms. 8r, 7r, 15r. Done with those. Constants, negative 14, 3, negative 11. We've accounted for everything up here. So everything's been used and put into the answer. This is my simplified answer written in standard form. All right, tonight, that's what you're going to work on. You're going to work on identifying, the parts of a polynomial, how many terms it has, what is its degree, put it in standard form, and you're also going to do some adding and subtracting. All right, I'll let you get at it.